Good day everyone and welcome back to my channel. Today, let's look at an example of a recursive sequence called Fibonacci numbers. Okay, so in simple, Fibonacci numbers is Fn. Okay, so when you say recursive sequence, there are two conditions that we might satisfy, right? So the first one is initial values, right? So Fibonacci has two initial values. F of 0 is equal to 0 and f of 1 is equal to 1. And then the next rule that we must satisfy is the recursion of the sequence, okay? And here, Fibonacci gave the recursion as f of n is equal to f of n minus 1 plus f of n minus 2. Whenever n is greater than or equal to 2. So let's look at when n is equal to 2. Okay, let's just substitute. So f of n, which is 2, is equals to f of n minus 1, which is 2 minus 1, plus f of n minus 2. So 2 minus 2, no? So here, we have f of 1, 2 minus 1 is 1, and then f of 2 minus 2, that is just f of 0. We have these two values here, you know? F of 0 is 0 and f of 1 is 1. So 1 plus 0 is equals to 1. So f of 2 is equal to 1. Alright? Next, let's try when n is equal to 3. We just substitute, alright? F of 3 minus 1, that is f of 2, plus f of 3 minus 2, that is f of 1. So we substitute. Our value for f of 2 is 1, and also f of 1 is 1. And so f of 3 is 1 plus 1 is equal to 2. We compute for f of 4, so it's just f of 3 plus f of 2. So 2 plus 1, that is just 3. We continue on with f of 5 now. So f of 5 is just f of 4 plus f of 3. F of 4 is 3, f of 3 is 2, and so 3 plus 2 is equals to 5. And that is our f of 5. Now, would you know what's the next number of the sequence? The f of 6. The sum of the two previous, correct? So that is 3 and 5. You add it, you get 8. And so on. This is your Fibonacci sequence. Thank you. See you at my next video.